finally, we look at Newton's third law. And just like the previous two, we've also looked at this in the different contexts in the sense of change in momentum. So remember, this is telling us that if we have two masses, so we have object A and object B, and they're colliding with one another. Okay, so object A is going to have a force FAB on object B, and object B is going to have a force FBA acting on object A. And remember, what Newton's third law tells us is that the force of A on B is equal to minus the force of B on A. So in other words, in magnitude, the force of A on B is equal to the force of B on A, but they're in opposite directions. And that's all Newton's third law says. But now let's remember, we looked at this in terms of momentum, because we said that the momentum of A final was equal to the momentum of A initial plus the impulse that it received from the interaction with B. And we said that momentum B final was equal to momentum B initial minus the impulse that it gave to A. And so recall that now we can just, if we change this to a subtraction, so the change in momentum of A is equal to the impulse. The change in momentum of B is equal to minus that same impulse. So in other words, we see that the change in momentum of A is equal to minus the change in momentum of B. But recall that force is just the change in momentum over the change in time. So in other words, the force delivered to A is equal and opposite to the force delivered to B. So once again, this is how we're connecting Newton's third law in terms of forces the way that it was originally stated, and connecting it back to the conservation of momentum, which is what we learned about early in the class.